Here we have an example of a phase line. We're considering the equation x prime equal to x squared minus 1 times x plus 2 squared. And so the first thing we'd like to figure out is what the equilibria are. Equilibrium points occur when x prime is equal to 0. This is factored for us as a polynomial. It has a 0 when x is equal to minus 2. It's actually degree 2, 0. And then it has a 0 when x is equal to minus 1. And when x is equal to 1, because then x squared is 1. And so let's see what the signs are for the rate of change of x. If x is below minus 2, x prime is positive. So obviously this term is always positive, and this term is this term when x is less than minus 1 is positive. So when x is less than minus 2, x prime is positive, and when x is less than minus 1, x prime is still positive. Then when x crosses from the left side to the right side of minus 1, this term x squared minus 1 flips signs, and so we have that x prime is negative. And then when x crosses from the left side to the right side of 1, this term x squared minus 1 flips signs again, and so x prime becomes positive again. So in terms of the behavior of the system, x equal to minus 2 is a node, and x equal to minus 1 is a sink, and x equal to 1 is a source. We're here looking at the phase line for x prime equal to x squared minus 1 times x plus 2 squared. We decided that the equilibria were at minus 2, minus 1, and 1. We like to put the x-axis vertically because we'd like to see how the behavior of the trajectories goes over time. We think of time as going horizontally. So at minus 2, x prime is positive on both sides of this node. Then minus 1 is a sink, we decided, and 1 is a source. So let's look at the trajectories. If we start below minus 2, then x prime is positive, and the trajectory approaches this node. If we start above the node with x between minus 2 and minus 1, the trajectory is increasing and approaching this sink. If we start above the sink but below the source, then the trajectory is approaching the sink. And if we start above the source, then the trajectory is increasing, x prime is positive, and moves off, presumably to infinity. We can actually solve this equation by partial fractions, but that will give us a pretty complicated expression.